51. Anything before 51. So it's Jack. Jack is not here. Anybody else have one before 51?
Didn't you say you have 47?
You didn't get 47?
I get like part of it, like part way, and then I get it.
Well, let's do that. I mean, those are the ones with the completing the square. And that's it. And after looking through your quizzes here, and I'll have those grades in shortly, probably by the end of the period. You have to look by the end of the period or Bearcat time. But yeah, I mean, that's the thing we've got to continue to get better at. It's gonna happen in this, and then the last one we do a little bit starting tomorrow. Hyperbolas are very similar, so we're going to go ahead and work on those tomorrow, and then kind of work on ellipse and hyperbolas together for a few days before we quiz on those. But that's what we're doing here. So, Allie, would you read me 47? X squared plus 4y squared. Wait, x squared plus 4y squared. Okay,
minus 6x plus 20y minus 2 equals 0.
Okay, so I kind of took us down a bad road yesterday, and then we kind of fixed that. So what I would do here, and it looked like a lot of you did a pretty good job of that. It didn't really affect as much, a little bit maybe on the bonus problem, but it's kind of the same thing. We're going to group the x's and the y's. So we're going to go kind of like this, and then maybe move the 2 over here. That would be my suggestion. Okay, group the x's, group the y's, and then get the number over there. Now, we do, like on this one, we don't have to do anything to that, so I'm going to go ahead and just bring that down, and again, leave myself a gap. And then here I'm going to take out this 4. And I just think this is the best way to do these, and that would be a 5y, and then again, leave myself a gap, and then I got the 2 over here. Okay, so I think you do need to factor that out like that. That's probably the best way to do it, because we get into dividing on these too early, and I think it's just not as nice. It can work, but it's a little messier. So on this one, we're going to fill in what here in the gap, in the blank? A 9, and so we'll get a 9 over here. Okay, but in this one, what's going to go in the gap here? Now, you can do decimals, or you can do fractions, either one. It doesn't matter. 6, you want to do 6 point, I'm going to let you use calculators on the quiz. So if you want to do 6.25, so the half of that's 2.5 and square it. But then what goes over here? 25. Half of, or excuse me, 4 times 6.25, because it's in those parentheses and there's a 4 there. So we got to take 4 times 6.25. Okay, that's the kind of the trick. So then this becomes x minus 3 quantity squared. The 4 is still over here. This would be y plus 2.5 quantity squared. And then over here we get 36, like that. Okay, so let's review that. So right here, remember what, and again, maybe there were, I'm not sure if there's anybody in here, but there were a few people who have this number wrong in here. Like, for example, you might have had a 6 here. Remember, it's half of that. Or whatever squared gives you the 9, so it's got to be 3. Same thing here. It's got to be 2.5, because 2.5 squared gives you that. Over here, we get 36. Okay, now we have to do what? Yeah, this is where it's a little different than what we did with parabolas. You know, parabolas, we want to get the x's on one side, the y's on the other side. You know, 1 over 4p on the correct spot. You know, here we're going to divide everything by 36 because we want a 1 over there. So we're going to divide by 36, divide by 36. Okay, so now we pretty much have it. We got x minus 3 squared over 36. The 4 cancels the 36 and makes 9. So we have y plus 2.5 squared over 9, and then over here we have 1. Okay, so was that all you had to do, was get it in standard form? No, you had to do center, folks, I know that. Okay, so if we take that, okay, so if we take that, okay, if we take this here and we go over here, okay, so that equation, and what happened to my 9? I lost my 9. Okay, so center is going to be 3, negative 2.5. What else do they want? We've got c squared is equal to a squared minus b squared, correct? That's something that's on your gold sheet. We got to have that. That's going to help us get the foci. Which one is a? The bigger one is always a, right? The bigger one is always a. So this is c squared equals 36 minus 9. So c squared equals what, 27? All right? So c is square root of 27. Now you can get a decimal of that, but you can do it in your head just, it's a 5 something. It's a little more than 5. Because what did it say to graph these? In sketch graph. So you might want to be a little more, but it's about 5, a little over 5, right? So now our center is at 3 and negative 2.5. I'm going to spend a lot of time getting the graph, but we get that. Now what did we do here? Since this is our a squared, remember, this is our b squared. So a is 6. Okay, I think that's good. Now why do we need to know what a is? Now here we used a squared and b squared. But what do we use a for? When we graph it. How far to go, right? On the major axis. That's on the long axis, the major axis. So that means from our center, we're going to go 6 this way, right? And we're going to go 6 this way. So remember, this was at 3, so this is going to be over here at what, 9? So this will be 9, so our this is what, our vertices, right? Remember, now the vertices, I didn't make a big deal about that yesterday, but the vertices are on the major axis, so that's what's considered the vertices. So the vertices and the foci are both on the major axis, okay? So the vertice, so one of them is going to be over here at 9 and negative 2.5, and the other one's going to be back here at what, negative 3, if this is 3, so it's 6 this way, 6 this way. Okay, so that's going to be negative 3 and negative 2.5, like that. Okay, the foci, that's where we use the c, the square root of 27. Well, that's about 5 something, right? It's a little bit less than the a is, which was a is 6. So c is going to be right over there, so it's going to be a little, right? But how far is this distance right here? That distance is square root 27. So how do we want to write that? We're going to write that as 3 plus square root 27. Does that make sense? Our x-coordinate is going to be 3 plus square root 27. And then our y-coordinate is going to be the same, negative 2.5. Okay? And what's this one going to be over here? We're going to go this way. Square root 27. I didn't really draw that in scale, really. But we're going to go that way, square root of 27. How will we write that? How do you think we'll write that x-coordinate? 3 minus square root of 27, and then negative 2.5. So all of these points have the same y-coordinate as the center, negative 2.5. It's the x-coordinate that changes. So you could have written this 3 plus 6 and 3 minus 6, right? 3 plus 6 is 9. 3 minus 6 is negative 3. Okay? 3 plus c, 3 plus square root of 27, and 3 minus square root of 27. That's all you have to do. If it's going this way, you just add it on and subtract it from the x-coordinate. If it's going up and down, you add it on and subtract it from the y-coordinate. That's all you do. Okay? Once you get that c value there. All right? What else did they want?
One was like E.
Oh yeah, I wanted to talk about that. And then is that it? So we don't have to worry about radius. We got the center, we got the vertices, we got the foci, and then the last thing, and then they wanted to sketch it. Okay, we've almost got it sketched. All we need is B. What was B here? B is 3. So that just means we go up 3, which would take us a little above there, and 3 would take us a little down here, and then we got our ellipse. Okay, and we got our ellipse right there. Okay, and the foci are inside of there. Okay, like so. And that, yeah, E is called the eccentricity, and it's just simply C divided by A. Okay, it's just C divided by A. And that is square root of 27 divided by 6. That's all you do. It's on your, I think it's on your gold sheet. Now we're going to talk here a little bit about that. Okay, if you wrote that out as a decimal, it's like, what is square root of 27 divided by 6? like 0.8866 something, okay? Now, and so we're going to talk here in a minute about that eccentricity, what that number kind of represents, but and we'll talk about it some more tomorrow too, okay? But that's just a decimal value, okay, that tells us about the ellipse, okay? And that's it, okay? That's everything, the important parts of the ellipse, all right? So what was the other one then? 51 you said? Okay, read me that one.
9x squared plus 25y squared minus 36x minus 50y plus 60 equals 0.
Okay, so again, take our x's and put those together, leave a gap, take our y's, put those together, leave a gap, move the negative 60 over there. So I take out the 9, so x squared minus 4x, take out the 25, y squared minus 2y, and then my negative 60, okay? So I got all of that. Now, what are we putting in the blank here? 4. What are we adding over here? 36, right? Half of 4 is 2, squared is 4. What are we adding over here? 1. Half of 2 is 1, square it is 1. What are we adding over here? 25. Okay? So we added a 9 times 4 to this side. We added a 25 times 1 to this side. And so now we get, what does that add up to? Oh, that's nice.
Yeah, I know where this
Adds up to 1. Now, this still does have kind of an interesting thing here. So it's not, I mean, you might say, oh, good, there's a 1 there. That's what we want. But what's wrong? What's wrong with it? The way it's written? You might say nothing, because that's what an ellipse is supposed to be. But it's supposed to look like, it's supposed to have nothing in front of the squares, right? Only stuff down here. So, what do we have to do? But we already have our 1 here, so we don't want to divide by anything. We want 1 here. What do we do with this 9? Timesing by 9, which is what's happening here, right? Timesing by 9 is the same as dividing by 1/9. So this 9 up here is the same as having a 1/9 down here. And that's what you do with that. Okay? Having a 25 here is the same as having a 1/25 down here. Okay? Now, likewise, if you had a 4x minus 3 squared over 9, like that, right? And you da-da-da-da-da, and you had your 1 over here already. Okay? Well, what you're really doing is timesing by 4/9 there, right? Timesing by 4/9 is the same as dividing by 9/4. So what you would have is that on the bottom. Okay? All right. So that's what we end up doing. So the a squared, and remember the bigger one, which one of those is bigger? 1/9 or 1/25? 1/9. So the a squared is 1/9. So that means a is 1/3. And the b squared is 1/25. And the b is 1/5. Right? And so then you would go, so it's going to be kind of a strange one, but when you go to graph it and do all those things, but the center, so the center is going to be at 2,1. But then for A, and A is under the X again, right? So you're going to go 1/3 this way and 1/3 this way, and only 1/5 this way and 1/5 that way, right? You're going to go very small amounts, as opposed to the last one where we went 6 and 6, right? So it's going to be a very small ellipse. So that's kind of an odd situation there. Okay. that's how we'll handle those fraction situations. So what would c squared be? C squared is a squared 1/9 minus b squared 1/25. And so I'm okay on this one if you just get that on your calculator. It'll be fine. Use a decimal, it'll be good. So 1/9 minus 1/25. 16 over 225, or as a decimal, whatever that is. And then so c would be the square root of that. So that'd be 4/15, right? 4/15, or you could use a decimal, it's fine, but you could use a fraction. Okay? And you can use your calculator to add fractions if you need to or whatever. But if we have a square root though, I do want you to just write it like this, like 3 plus square root of 27, 3 minus square root of 27. Unless it comes out nice, obviously, like square root of 25 or something. But most of the time, a lot of times C doesn't. A lot of times C is a square root. And sometimes A and B are, right? And you might not always get perfect squares under here, right? You might get a 12 under here. Then the B is square root of 12, right? So, but in your head, you know square root of 12 is about 3.5 or so. You can get a decimal. At least you can graph it, right? And kind of get it in the right spots. All right, so that's kind of our focus right now for ellipse. Let's talk about that thing called E. So yesterday we put this in our notes. We said A is always bigger than B. C is the distance from the center to the focus. So C is this distance right here. So we did in our notes yesterday, right? And C squared is A squared minus B squared, right? And A is always the longer one. A is longer than B. So if the A is under the X, that's going to be long this way. If the A is under the Y, it's going to be long up and down, because that's how you tell which way to go. So remember A. So and on the quiz, there are a few people that mix that up like on circles, right? The equation has r squared at the end, but when you want to graph it, you got to do the square root of it to get what r is. So the radius. Well, same thing here. When we draw this, we want A and B. So we want the square root of these numbers for how far to go, right? So A is how far we go from the center. If the A is under the Y, we go up and down A. For the focus, we go up and down C. Okay? C and A are always together. They're always on the major axis. All right? They're always on the long side. Okay? If the biggest number is under the X, then it's going to go horizontal. And then this thing called eccentricity. Okay? So let's just talk about that real quick. It's just the ratio of the focal length to the vertice length, or the major axis length. Okay? So if C and A are really close together, if the focus is really, really close to the vertex, then you have kind of a long, skinny ellipse. In other words, the focus and the vertex are almost the same, right? Then when you divide two numbers, if you divide two numbers, and remember, A is always bigger than C, because C, the focus is inside the ellipse. So A is always bigger than C. So you know in this fraction, the bigger number's on the bottom, the fraction has to be less than 1. C will always be littler than A, so this fraction has to be less than 1. So that's why we know on ellipse, E will always be between 0 and 1. It's always going to be some decimal. Now, if it's close to 1, that means C and A are pretty close to being the same. If C and A are pretty close to being the same, Jack, you should have heard what Allie called you. If C and A are pretty close to being the same, I don't know why, I just randomly thought of that. But
all he said was Jack asked all the time.
She said something about it. Jackass. I don't know.
It's not the worst thing I would have said.
All right. If C and A are really close together, that fraction is almost 1. So like 0.8, like that last one we had, the 47, it was a pretty skinny parabola. Or not parabola, ellipse. It was pretty skinny. It went 6 this way. It only went like 3 up and down. Okay? That's because we have like 0.8 something for our eccentricity. Okay? If you get an eccentricity close to 0, that means that C is pretty small. A fraction where the top is pretty small, that means you're going to have, so in a ellipse, it's almost a circle. The foci are like way in here. C is pretty small. So the more of a circle it is, the more the foci are in close towards the center. Okay, and the closer the foci are out to the ends, the more elongated it is. Okay, so just kind of a measurement of, so all the planets, so like in your book, and you don't have to turn to it here, but in your book on page 747, they've got the eccentricity of all the planets' orbits. And they're all like 0.02 and 0.08 and 0.06, pretty small. So most of the planetary orbits are fairly circular. They're ellipses, but they're fairly circular. And the sun, and some people think this wrongly, the sun is not at the center. The sun is one of the foci. The sun is, so when the planets, as they go around, as they go around the sun is not in the center of their orbit. The sun is at one of the foci of the orbit. And the same thing with the moon's orbit around the Earth is an elliptical path, and the Earth is at a foci, one of the focus points of that ellipse. Okay, so that's just one example of probably the most famous example of an ellipse. Another couple cool things about an ellipse. If you've been to Washington, D.C., anybody go there for that 8th grade trip, whatever, in that statuary hall where they tell you about that, in that room where the ceiling, it's like a semi-ellipse, half ellipse, and if you stand at the two foci, if you whisper at one spot, then because what's happening is in your ellipse, wasn't very bad. Okay. I surprised myself when that happened. So all of the sound waves are going to be reflected, just like we talked about with a parabola. All the sound waves that bounce off are going to be reflected, and up to the ceiling or whatever, are going to be reflected back to this area. And that's why, if you're a long ways away from somebody and they talk, those sound waves, disperse all around, and by the time they get to you, it's pretty, if you're up close, you hear more of them. But that's what's happening. That's what's happening is because of that elliptical shape. And so one person at one focus, one person at another. If you had an elliptical pool table and you had a pocket here and you put a ball there, as long as you didn't put some spin on it or something, you would make it every time. You just, no matter where you hit it, it would bounce right into the other spot, which would be done. I've never seen one, but if you had such a thing. But again, if you put spin on it or something, that might make a difference. But that would be a few applications, a few things that are related to ellipses. Okay, so we'll just kind of stay with kind of the same kind of stuff, the same kind of practice on these. Just a handful of them to do for tomorrow. So mostly it's like, what's that?
Yeah, no.
We did those.
Oh. Those are the ones we already did. Oh, okay. Yeah, so here's all my, oh gosh, geez, I rewrote those all. I had it all written out already. I forgot. How did I forget? Over lunch. I had all those written out, and I just went through them again. Okay, there was 51. Yeah, that's what we came up with. I did like double the work. Okay. I need to rest. There you go. There you go. There you go. Yeah, so when I say we'll do some more of the same, I was literally saying you can do more of the same. All right, so do these with some ellipse problems tomorrow. We'll introduce hyperbola. So you get, some of you are going to be on tomorrow?
I'm going to be on.
Okay. And you'll be on Thursday?
That's why he gave these last 30 minutes.
Yeah. So there'll be a video for tomorrow's thing. And then Thursday is going to be more review because I won't be here either. So Thursday will be some ellipse work and activity with ellipses, and a couple other kind of problems to work on. And then Friday we'll come back and do some more hyperbola stuff. Probably review again next Monday, all of that, and then probably a quiz about Tuesday. Okay.
What did you say the last
Hyperbolas, which is the last of our conic sections. It's very similar to what we do with, but it's very, very similar to what we do with ellipses. The equations look very, very similar. So when it comes to completing the square, we get the 1 on the other side, all of that stuff. So it's very, very similar.
Did you guys just take the test?
We just did the quiz before lunch is all we did. So. Was there,